I'm here with Dr. Susan Friel again, and we're going to be talking with earlier you had heard her mention some of her favorite data sets, and we're going to actually talk about some of those today. So I know that in a lot of your work you use a software called TinkerPlots, and we're also giving our participants an option of using that software as well in the course, and it's a popular one used in middle school settings. So we're going to talk about one of your favorite data sets. It's a cat data set that has, I think, 200 cases in it.
This one does,
This
yeah.
one has 200 cats in this data set. So tell me a little bit about the data set, kind of where it came from, and what some of the attributes are in it.
Okay. Way back when, quite a few years ago, when I first got into doing statistics software for schools, I worked on an elementary project called Use Numbers, and the co-PI who worked with me was a lover of cats. So one of the data sets we put in the fifth grade curriculum, I think, was a data set of 27 cats, and it was data from their friends and from themselves in terms of what they were using. And actually,
It's a lot of cats for a few people.
Well, they're friends too. It actually is still on TinkerPlots. That 27.
It comes with
a
a sample
set.
data set.
Yeah.
Yep.
Right. And so whenever I've done workshops with teachers around statistics, we had a big project in North Carolina called TeachStat many years ago where we did 2 weeks of professional development. One of the things we did was get a cat database, and then when we use that to motivate statistics. So what you see on my screen is a picture of a data card. Every time I do this, I make some data cards to go with the group of teachers I'm working with. And you see a cat named Sasha, and Sasha was my cat. And she was, at the time, was a female, was 13 years old, weighed 11 pounds, body length was 19 inches, tail length was 11 inches. Her fur color was white, ginger, and black. Her eye color was yellow, although you can't see it. And her pad color was pink and black. And then she's Ginger's sister, who also lives with Annie. And Ginger and Annie were my 2 other cats at the time. And so, first of all, you see I have a bunch of attributes. So when we think about a data set, we talk about, well, what are the attributes that are we can collect data about? And then you can go home and do this measurement. Indeed, we have a little diagram that teaches kids how to go home so that they can actually weigh a cat. And I don't know if you know how to weigh a cat, but the way you do that,
scratched.
well, the way you do it is you step on the scale and you weigh yourself, and then you step on the scale with the cat in your arms and hope that it doesn't wiggle, because it will wreck the weight if it does. And then, or you can do it first, weigh the cat and then weigh yourself afterwards. That's how you can get the pounds. The body length is measured from the tip of the nose to the base of the tail, over the head. And the tail length obviously is from the tip of the tail attached to the body to its end. And fur color, you have that. So there's some numerical data we have, and then there's some what we call categorical data that we have about each cat, which makes it very nice.
Yeah. So with the pounds and the inches, so when these measurements were taken, or if students are going home and measuring on their own cats, are they directed to how they're supposed to round as far as pounds, or as far as inches? Are there any particular measurement issues that might come up?
They could. Typically, they're using a scale in your house. So they could get tenths.
Yeah, it depends on the brand of the scale.
Yeah.
If
And
it's
so,
digital.
and actually, I may have some that have like 7.5 or something like that in terms of weight.
Yeah.
And some of them will measure 11 and a half inches or something like that. Typically, they're measuring pretty quickly, so they're not often
Right.
but some get
You can only have that cat
preoccupied
stay
with the
still
parts,
so long.
right? But it's very simple, tenths of an inch or something. We have never used metric. We always used the English system because of the weight and everything we were doing. And why I like this data set is you can use it to work with kids, even just the 27 cats. And if the kids want to, they can add their own data, which then helps them make it their own as well when you're doing it.
That's nice. All right, so let's open up TinkerPlots. I see you getting this open, and tell us how Sasha's card or a card from a different cat would be represented over here.
I'm not sure where Sasha is, but I'm pretty sure she's in this set.
Okay.
I have used a lot of different software, and I, excuse me, I worked with Cliff Canold, who developed TinkerPlots. He had the middle school projects working with him. So I was quite active with giving him feedback. I think this is the most exciting piece of software I've ever seen.
Yeah.
And
I
I've
agree.
used it with kids, and it's very engaging. This is a pretty large data set. This is 200 cats. I probably would start with 27 with kids because they're going to explore it first. But you'll notice on the left side, you'll see that you see the same attributes listed. Name, gender, age, weight, body length, tail length, eye color, and pad color. And notice that for this cat, Speedy, that belonged to somebody, I'm not sure, because I collect these from my teachers when I work with them.
Uh-huh.
And at the time, you'll see that the unit of measure for age was years, and they reported that he was 0.17 years old, which I don't know how many months that would be, but that's probably how they got it.
Yeah, yeah.
This is one with weight where they have 3.5
3.5,
pounds. Yes.
Mhm.
Body length is 15 inches and tail length is 8 inches. And so we have this array of data in here. With the one with 27, you can do the same things I'm going to do with you, and it might be easier with them too. So part of it is the attributes signify with their coloring the kind of variable you're dealing with. So if I click on gender, what do you notice about the color of the icons?
Yeah, we only have 2 represented.
2 represented. And what's neat about these is they move around the screen. If I do this little circle down here, mix up. And what I should do is put my sound on
So
for you.
each of these dots is a case.
So I'll click on a dot here and watch the table over here. That's Trooper.
Yay.
And here's Lucy.
Mm-hmm.
And here's Pink Lady. So each of those is a case, and if I also have a spreadsheet-like table I can have open, which will be linked. So there's 3 things that link together when you're doing it.
Yeah, yeah. And I think it would be very important when students are first starting to use this software that make sure that they understand the links between all of these different representations.
Well, with the 27 cats, to be honest with you, because I still have the cards, that you saw the cat card with Sasha. I have a set of 30 cat cards that go with this data set, but with the 27, we actually have all 27 of the cats as cards as well. And typically what we do with kids is we explore the data cards first. Then we come back and we look at the computer and we talk about how the data cards actually connect with the representation on the computer. They don't have much trouble with this in terms of working through it.
Yes,
So.
yes. I have worked with students and teachers with this software, and it is
So you know.
it's extremely easy to
Right.
use. Yep.
Well, there's this little thing down here that lets you mix up the icons, and you hear the sound. I once worked with a group of kids who really got into just doing this.
Yes.
They
yes.
like the sound and seeing it mixed up first, so.
And as a teacher, you learn how to turn that off.
Right. You can just turn your sound off and you won't hear it anymore. So one of the first things you can do on this is you can separate the data, and you just click on an icon and you drag it. So you'll notice that all the purple ones went to one section, and all the greeny yellow ones went to the other section. And lo and behold, one group is male, one group is female. And if we want, we can stack them.
Yep.
So you see them stacked. Looks like it might be 100 male and 100 female.
It
but,
sure looks that way.
but we can actually go up here and turn on. No, that's not what I want to do. I want to label.
Do we want the N?
I want the end. That's what I
There
want.
we go.
Yes. Yes, there are 100 of each. So this is sort of a fixed database.
Yeah. There is purposely chosen 100 males and 100 females.
And if you wanted to actually see the key to this, you can even put this little key up and it tells you the colors that
Yeah,
you're working with.
that's
So
nice.
it's very nice. That's nice.
So I think it's interesting that at times when you're first getting students to kind of think about data, there's this playful kind of period. And what I see you doing, I mean, you're telling us a lot about the software, but you're also just starting to play with different ways of kind of organizing it. And that seems like it might be an interesting and important thing for students to do.
Yeah, it is. It's very nice. So you won't get any of the formal histograms or things like that on here, but you can do box plots and a few other things. So if I turn off the N and I mix everything up, notice what happens when I click on the next variable, age.
Yeah, I've got a gradient.
Yeah, you get a
From
gradient.
like a white to dark red.
Right.
Or dark pink, it's hard to tell.
Right, and actually if we turn on the key, you can see that it actually goes from 0.17 years old to
Kitty, kitty,
18
kitty.
years old. So that's actually the ages that we're talking about. Now,
Mhm.
again, I can mix them up.
So
But-
these are just randomized placement on the screen to
Right.
show that there's no order.
And if I click on this one, that's Diva, and she's 3.5. She's 3.5 years old.
Mhm.
And so that tells you. And if I click on a dark one, there's Bart, and he's 16 years old. So the darker colors are the older ages. Now, again, I can drag. Now I can start to drag, and you'll notice that it starts to section the data.
Yeah.
I'm a big one for just dragging all the way. And so you see it shows from 0 to 18 as the years, but it's all spaced out above. And of course we want to stack it.
Mm-hmm.
So I just stack it like that. And sometimes I spread it out a little bit. I can go down here and make my icons a little smaller.
Yeah, nice.
But some people get bothered by how they sort of lump over each other, but I don't. It sort of gives you the idea of where they are.
Right, right.
So this is actually the distribution of the ages of the cats that are in this database.
Mm-hmm.
And it goes all the way to 18 years. And you'll notice that I have a lot of young kittens, don't I? A lot of young cats.
Yeah,
But I don't have a lot of data on old cats.
yeah.
Cats actually live a pretty long time now, but for these people, that's what they had.
Right, right.
Um,
And that seems like an interesting thing to point out, that this data set isn't necessarily a random sample of cats that we could then make any type of inference about all cats, but this is just a collection of cats that we happen to be studying.
Right, it's a convenience sample.
It's
I
a
got
convenient
the data
sample,
from
yeah,
the people in the
yeah.
group.
You know, so we couldn't infer necessarily from this data set that cats don't live a long time.
Right. Now, one of the questions, if you look at weight, so this naturally lends to some comparative questions very quickly. So if you look at weight, you might wonder if the older cats weigh more, right? So what I can do is now I'm going to click on weight, and you'll notice that the icons change color.
Mm-hmm.
So that's showing me the weights, but it's pretty hard to sort of tell by just looking at the colors. You can see a lot of the light colors, which is the low weights, are down here, but you
Right.
start to see the
All the oranges are kind of spread out
out,
in there,
right.
yeah. It doesn't look like a clear pattern to me.
No. And so what I absolutely love about this software is you can start to drag up.
Uh-huh.
So if I just click an icon and start to drag up.
Because you were thinking you want to see this in a two-dimensional.
Right.
Yep.
And I can actually drag it further if I want to. So we start to get even smaller intervals. So you
Mhm.
see, notice these cats here, and here's one that's very small at 6 years old. They're only between 0 and 3.99
Pounds, yeah.
And then we start to get up here. So our question was, do older cats weigh more?
Mm-hmm.
So the question is, what do you think? Because here's our weights, and here's our ages. And so you start to see the heavier weights are up here, and the ages are over here. We could actually put in a little reference line if we wanted to, and just say, well, let's just say 12 pounds and more is heavier. So here's where 12 pounds and more is.
Mm-hmm.
I'm sorry. Ages, yeah,
Ages.
ages 12 and are older. And here's the weights. And you notice that actually the weights are variable
Right.
about the cats.
Right.
Um,
All right, you have several of the different weight categories represented.
Right.
Yeah,
So you can
Weight
actually look
intervals.
at that.
right.
Um,
And what I find interesting about what I just saw you do, and I have seen children do this as well as teachers who are learning to play with data sets, is you start looking at one variable and all of a sudden you have a question particularly about that variable. And then you wonder how it might be related to another variable. And I think that's a beauty of having data sets that have multiple variables in it that you can explore.
Right. And I will tell you, as teachers, this data set naturally leads to what we call covariation, which is how does one data vary with the other. And I actually can turn off this reference line and pull this fully all the way through, and you see a kind of scatter plot.
Yeah,
Not a well-related scatter plot. The
No.
data's all over the place, and so it's not fitting in a line or anything, and there's no way to draw a line of best fit here. But I can go all the way and look at the data in relation, age and weight, and how does it, and it's very scattered, so there doesn't appear to be any relationship to it.
yeah, yeah. And it's
Um,
just important to give students opportunities to see data sets where there's no relationship as where there is a relationship.
Right. And so part of it, we could check, I haven't thought about this, but I haven't looked at this in a while, but we'll mix up.
Mhm.
Here's body length. And I'll stack it. And then let's just look at tail length.
Mm.
I don't know how that will
So
look.
do long body cats also have long tails?
Right, do long body
Perhaps.
cats also have long tails? Doesn't look like it, does it? Maybe if I pull it down a little bit, then we can see the categories. Again, here you've got longer cats.
Mm-hmm.
Well, you
Yeah.
got, well, I think it's just,
Yeah,
that's interesting, yeah.
because the longer bodies, so let's say, 24, there aren't any 24-inch cats that have,
Tail lengths this
le-
way.
yeah, they're all 8 and above.
Right. And these little cats, they of course couldn't have the long lengths, because there is a proportion.
Right.
But cats actually have once they get to a certain point, they can be big, but their tail lengths stop
Yeah.
getting
Yeah.
big.
And one of the things that we want students to do is to be able to informally kind of describe these relationships, that we don't have to be rushing to formally describing everything with a linear regression or with correlation and things like that. But
Right.
we need these informal experiences to be able to just think about, what does it mean for two variables to be related to each other.
Right, and as I said, kids naturally ask questions about the relationships for this data set. So this is a good data set for it.
Yeah.
Now suppose that you want to just look at weight, and we'll just, let me get weight again.
Yeah, I see. Are you going to look at this question that you
Typical,
have? Yeah. So the question that she's thinking about is, what's a typical weight for cats, and do males tend to be longer, or way longer or is it
Way more.
way more?
Tend to
Be longer than females, but
Well,
we could
we could
also
talk about
we could
weight.
also talk about weight.
Yeah,
Do
so
males
here-
tend to weigh more than
Right.
females?
So here's a distribution. We might talk about typical, and kids actually look at clumps of data. So they would look at the middle and say, well, there's a lot of
I
cats
see a lot.
between 8 and 12 pounds.
Yep, I would have claimed that would be
Right.
a nice middle too.
But you can get, this software will mark the median. So it shows that 9 is the median. If you want the numerical value of the median, you can show it.
Mhm.
So it will show you the median, or I can turn the numerical value off. And then the little arrow marks the mean, which actually turns out to be,
About the same.
yeah, it's 9 point, I'm going to turn the median off for a minute. It's 9.0475. So that's
Mhm.
really interesting. The mean and the median are almost identical in this set of data,
Mm-hmm.
which is not always that common.
Right. Right.
So the
right.
software lets you mark those, and you can mark the mode too, but I generally don't spend much time with the mode.
Mhm.
You know. But male, female, let's go back up here to gender. So again, we can do this separate thing and separate them into two groups. So
Yeah.
here's the males up here, and here's the females up here. Here's your median and your mean for your females, and here's your mean a little bit lower than the median for the males.
Mhm.
Between 10 and 11 pounds here, and this is 8 and 9 pounds. So what do you think? Do females weigh less than males?
It seems like, in general, there tends to be that the females are slightly less. I mean, we certainly see similar ranges. I
Right.
mean, they're both the males and the females have variability in their data set.
Right.
So, which would be expected, since we knew the ages of our cats. So one of the things we're not controlling for here is the age of the cats. We're not
Right.
comparing older cats only. But the male cats tend to have a little bit higher weights.
Right, if you want to put on age for the color,
Yeah,
you
this
can
is one of
see
my
that.
favorite parts. This is one of my
We
favorite
can't
parts of
do
the
three-dimensional
software.
on this, but you can see
Right.
weight and gender and age, and you can see the younger cats at least
Yep.
have the lower weight
Yeah.
in both categories.
Absolutely. So
And
right
then-
now, we're looking at 3 different variables in this data sets, and I'm here to tell you that middle school students are very capable of coordinating their reasoning with 3 variables.
And look at the dark red,
Yeah.
and those, watch the ones that are,
So the dark red are the older ones? Yes, they are the older ones.
Right,
Mhm.
right, right. And so they're spread out. I mean, you do, older cats do have a tendency to weigh less, but then you can have bigger cats that weigh more too.
Right, right. I had a male cat that was 20 pounds.
I have one right now that's 18.
Yeah.
So, yeah.
Yeah.
And so they weigh a lot. And so if we turn that off, what do we have? Do male cats tend to be longer than females? So
Ah.
what we could do is body length.
Right. So we can leave the male,
I'm sorry.
That's okay.
I can undo that. You want me to go back?
yeah.
Okay.
So we have males and females already separated. I'm thinking we could just substitute body length for weight down here.
We could. We could just drag it down here. You're right. We could just drag it over here.
And we see now the body length, the distribution.
For the females and
Uh-huh.
for the males. Now here's the median and mean for the males and the females. It looks like it's pretty close.
I think so too. I see a lot of overlap in those distributions, whereas before I was seeing it a little bit more separated.
And I think this data up here might actually pull the mean a little bit this way that you're doing.
Oh, absolutely. I would think that would be.
Right. So the medians are really close. It's like 18 and this one's 19.
Yeah. So let's hide that data case. There we go. Hide selected
Case. There you go.
There we go. So we
So
have
that's
hidden,
good.
so that, if we take that case out, now we only have 199 cases
Right.
being shown in our graph here. And that lowered our mean and our median
Right.
for the males. Yeah, nice.
So this does a nice job of letting you explore some of the concepts. We can, if you want to see what a box plot looks like,
Mm-hmm.
we can actually do this right now. I'll show you how a box plot works on this. I don't want to do the hat, sorry, that's not the one I want. I want the
Yep,
box
there
plot.
we go, box plot.
And so there's a box plot, if you remember what they are. I'm going to shrink the icons so you can't see them.
Make them just a little, there you go.
Okay, so you can
I
see.
actually like to see both.
Right. And what's nice with the box plot, if you remember, it's possible to do outliers. I don't know if there are outliers here or not. Oh, there are.
Yes.
So here we go with our box plot. The middle 50%, the inner quartile range, tells us where 50% of the data are. And 50%. And kids will zero in on that as a way of describing it. And then you'll notice that some of these upper values, both in body length, are unusual when compared to the rest of the data. When using the guidelines for how to determine outliers when you do box plots, there's
Yeah.
some unusual values there. The box plots themselves, the inner quartile ranges are very similar, and the males are shifted only slightly to the left.
Mm-hmm.
So what was the other one we were looking at? We were looking at, was it weight we were at before?
Yes, we were looking at weight before.
Let's put that one back down there, just for the heck of it. All right, so there's the weight
Ah.
one. There are some outliers. There's a few little outliers over here.
Mm-hmm.
But notice there's a bigger shift.
Exactly. I
With the
see a
males, and
different shift.
notice the line in the middle that's the median. The median is shifted higher too.
Mm-hmm.
So box plots are very handy for doing
They really
that
are.
kind of thing.
They
Yeah.
really are. So at the end of an investigation like this, when students are starting to make kind of their final claim or their interpretations of the data, trying to make what their final result might be, what do you hope that they're going to do when they're in that final stage of trying to explain what they found out?
Well, actually, I've done it, and the kids have turned in their graphs and things like that with this. But so, what's a typical weight for cats? I'd ask them to talk to me about what they think is a typical weight, and they might start off with all the cats, and then they'll go. They might split it up just this way. Kids do have a tendency to not want to choose single values
Mm-hmm.
for the mean and the median. But then we ask is if we had to pick one number to try to describe what might be the typical weight.
Right.
Why might we pick the median? Why might we pick the mean?
Right.
And so the idea of a single number describing a set of data is important. But
Yeah.
typically they look where the data have a tendency to congregate or clump,
Uh-huh.
and they try to do that as well.
Yeah, which I think is actually very valuable because as we were talking about like weight times earlier, that a single value, you can always expect some error
Very
around that.
variable,
And
right.
so being able to describe kind of a central tendency both with an interval of, okay, this is where most of the data is. I could describe typical as 8 to 9
Mhm.
or 8.5.
Right.
Um,
And the other measure, which this one does a plot for, but it doesn't give you the measure, that mean absolute deviation that crops up in 6th grade now, I have come to appreciate it as a measure.
mm-hmm.
Because the kids really, it's much easier to look at this.
It's computationally easier.
Right, but it's also easier, and I don't know what it is here, but it is easier to talk about a measure of center and then say, but the data vary around it in this
Yeah.
way, and that's
Yeah.
what the mean absolute deviation does. So that idea of wait time in a line is saying that typically the data vary around the mean as much as this, high or low.
Right.
And that's really what you do. And once you know that, as well as the measure of center, you sort of have a good picture of your data set.
Yeah, yeah, that's a nice way of being able to describe that distribution.
Right.
Yeah.
It's very
So in your final claims, you want them to be using appropriate measures, kind of maybe using a couple different things to support their reasoning, and making sure that it's highly connected to the context. That they don't just say, well, the mean, the typical weight for cats is 5. That they give, it's 5 because, and this is, that most cats weigh, and kind of making sure that they are connecting that with the context.
And then they might come back and say, but if you look at the males and females, it looks like the males weigh a little bit more than the females because
Right.
this is what the mean is. They might not do box plots because they might not even know them at this point.
Right, of course.
But they might look at that and say, use that, and they might look at some other things too. So
Yeah.
there's a richer discussion.
Yeah, yeah. This was fun, looking
Yeah.
at this data
Yeah.
set. And hopefully it's inspired some of you to think about how you might get kids engaged in exploring an interesting data set that you find or that you create yourself.